Okay, this problem is kind of a modification of problem number 94, and what I'm trying to solve for here is the molar solubility of magnesium hydroxide when it's dissolved in 0.052 molar Mg2+. Now, this problem is very similar to your homework problem number 91 because you're given a common ion and the KSP, and you're trying to find out how much more of this salt will dissolve. So we're going to do an ice. We don't care about this. Now, we have magnesium 2+, so we start out with 0.052 molar. And we start out with no hydroxide. My change when I dissolve, oops, there should be a little 2 there, is going to be plus 2x and plus x. I know that because this is 0, and so some of this is going to dissolve to make that not 0. I get 0.052 plus x equals 2, and we have plus 2x. Now we know KSP. KSP is 8.9 times 10 to the negative 12th, and that's equal to 0.052x, nope, 0.052 plus x, and 2x squared. Now, we get to do something fun here. Because this is so small, we can neglect the x for 5%. You have to write that. Okay, then when we solve for x, we're going to get 4x squared times 0.052 equals 8.9 times 10 to the negative 12th. And when you do 4 times 0.052, 4 times 0.052, we get 2.08. And then we take 8.9 times 10 to the negative 12th, and we divide by 0.208, and then we take the square root, and we get 6.54 times 10 to the negative 6th is x, and x is the molar solubility of magnesium hydroxide. So this is that molarity. And the last thing that you should do is you should check, is this number less than 5% of 0.052? So let's do it. 0.052, 5% of that is 0.05, and it's 0.0026, which is much greater than 6.54 times 10 to the negative 6. So it's a fair assumption to make. Okay, this should help you do your homework problem number 91, but you also have homework problem 93, which is a little bit trickier. Okay, in 93 you're given, it asks us what mass, but it gives us a KSP and the zinc initial concentration. So you need to do an ice, and you will solve for the amount of, let's see, you're going to solve for the molar solubility of zinc sulfide, just like we did. And then you're going to use that molarity, and you're given 300 milliliters. So you would use that molarity. If we wanted to do it for this one, we could use this molarity, and we're given 300 milliliters, so we can multiply by 0.300 liters, and that's going to give us the moles that will dissolve. Okay, and then you need to just turn that to grams, so you'd use your periodic table to go to grams. So number 93 has an extra step. Number 91 is really straightforward. Number 97 we did on a different podcast, and you just had 101 and 102. And I'm not so concerned about 102. We will go over that one in class. Just tell me which one will precipitate out first for 102. Okay, thank you.